Okay, class. Last time we have discussed the first method of Anova. That is one-way Anova. And last time we are talking about, when we are talking about one-way Anova, we know that we are dealing with one factor. Okay, we have one factor. Okay, we have one response variable. Okay, this is what we call as independent variable. And then this is what we call dependent variable. Okay, we have a few levels of factor that we call treatments. Okay, we have few treatments. Okay, and then okay, that would be for one-way Anova. Now for today we are going to see how if we have more than one factor. Okay, means that our factor, we add one more factor. Okay, so this is where we call it two-way ANOVA with replication, or the other name for two-way ANOVA with replication is two factors factorial design. So if you see one of the name, okay, so you should know what you are dealing with. Means that now you are adding one more factor in your analysis of variance, and the rest are still the same. Okay, you have two factors, one response variable, few treatments or few factor levels, and then we have experimental unit. That would be the basic term for ANOVA. Okay, now what about two factor factorial design that you should know, or two-way ANOVA with replication? Okay, so among the things that you should realize is that the first one, it involves two independent variables or two factors with one dependent or response variable. Okay, so that would be number one. Secondly, the first factor refers to factor A effect on the response variable Y. So we are always talking about the effect. Okay, so the first factor is factor A effect on the response variable Y. Okay, and the third one will be the second factor refers to factor B effect on the response variable Y. So we are talking about the effect of each factor towards the dependent variable or the response variable. And the most important thing will be this one. Okay, so the interaction effect refers to the interaction of different level of factor A and B on response variable Y. So we will see how when we are talking about interaction of different level of factor A and B. So this will be the one that will be our main concern when we do two-way ANOVA or two factorial design. Okay, and among other things that we have in addition for our two-way ANOVA with replication is the number of replication known as R, the number of level of factor A, okay, or we can last time we call it as treatments. Okay, treatments for factor E. Okay, and B, small b, is the number of levels of factor B, the treatments of factor B. And then we can also have row total, we will have also column total, and we also have cell total, and finally we would have gram total. What are all these? Okay, we will see later. So just want to mention to you that this will be among the things that will repetitively being used during discussing the two-way ANOVA. Now, if you can see on your textbook on page 134, okay, page 134, so you can see these different types or different example of two-way ANOVA. When we say two factors, we will have our first factor, factor A, and second factor, factor B. Sometimes it will be arranged vice versa. It could be factor A here and factor B here. Depends on how you define them. But it's okay as long as you know you are referring to what for your column and what for your row. So it will be okay as long as you understand the effect of this particular arrangement. So if that is, you have two factors A, two level of factor A and two levels of factor B. Okay, so what you have inside would be A1 and B1. This is what we call as the interaction effect of factor A and factor B. And this one is the interaction of effect of factor A1 and B2. This one is the interaction effect of A2 with B1. And finally, the interaction effect of A2 with B2. Okay, so this will be for 2 by 2 level if you have factor A and factor B. It could be also in terms of 3 by 2, means that you have 3 levels of factor A and 2 levels of factor B. So you will have this kind of arrangement. Okay, so you can see the interaction of each of the factor level for A and B. Okay, and finally, you can also have 3 by 3, means that you have 3 levels of factor A and 3 levels of factor B. Okay, and what does this has to do with your table of total? Okay, so if we represent our table of total, okay, so what would be the things that you should highlight from here is this one. Okay, you can have your row total. Okay, this is the total for the first row. I mean for the first factor, level of factor A, level 1 of factor A. This is the total for level 2 of factor A, and this is the 8 level of factor A. Okay, so this is the what we call the cell total. It means that you are going to add the response variable value, and then you will get the summation over here. Okay, so this will be the summation. Summations of factor A level 1. Okay, so you can have also for level 2, okay, and also the last one will be level 2. And you can also have your column total. Okay, so the column total will be this one. This is your row total, and then this is your column total. Okay, so this is the column total for, means that you are going to add all level of factor A level for first level, second level, and 8th level. So this will all be the column total. Okay, and you will also have your row total. Okay, so just now you are going to do it this way. Okay, you are working this way, column wise. Now we are talking about row wise. Okay, so that's why we can have our column row total, sorry. So this will be your first row, second row, third row as the 8th row. Okay, this one should be just now should be working this way. Okay, so this is by column. Okay, just now by column means that you are going to look one column to another column. Okay, so now you are working with row. Okay, so you will have your row, first row, second row until the 8th row. Okay, so from that you will have what we call table of total. So we are going to see the example of table of total when we do the example afterwards. Okay, so by now you should know how to find your column total. Okay, and from the column total you can also find the means. Okay, means of all of the column. How to find the mean? Okay, so this will be the overall total. So you divide the by the number of sample for the first column. So divide by the n. The same goes to the second column until your D column. Okay, D column, sorry. So this one is P. Okay, and this one is P. So then you will have also your row total. Okay, and then from your row total, you will have your means of the row. Okay, so here you will take the value, the summation of all the value inside the first row, and then you divide by the number of sample inside the first level. That would be level 1. So you divide by the number of level 1, so you will get your row means of the first level. Okay, so that will be basically how you can find your table of total, and from your table of total, you can have your table of means from your table of total. Okay, we will see later. Now, what else should you know about this particular setting of 2 by 2? I mean, or for example, 2 factors. Okay, for example, if this is the setting that you have, okay, regardless of how many dimension for column and dimension for row, okay, so the one that we are interested in is the total variation. Okay, means that the total variation is coming from all the samples or your response variable that you have selected. And this total variation for the whole sample that you have will be divided into 2. The first one is the explained variation, and the second one being an explained variation. And also, as usual, the unexplained variation is what we call our error, or we always see as SST, sum of square error. This is the one that we don't know, and it will just automatically appear in your experiment. And for the extreme variation, okay, you will have 3. Now, last time when we are talking about one-way ANOVA, we only have the extreme variation is from the factor. Okay, now since you have 2 factors involved in your setting, that is factor A and factor B, definitely there will be variation from the factors that you have. That will be variation for factor A and variation for factor B. And since we are talking about the interaction, now we are talking about the interaction between level 1 of factor A and level 1 of factor B, and we have the response variable here, the result that we gathered. Okay, now we believe that the interaction, this interaction will contain some variation. That's why we will have the next, the third one will be variation from interaction between factor A and factor B. That will be included in your ANOVA table later on. So this will be the sources of variation. Now, everyone should understand, okay, when you are talking about two-way ANOVA with replication, okay, so you should have in mind that this will be the setting of your variation that will be included in your ANOVA table. And when you are talking about one-way ANOVA, how then it will be differ from this particular two-way ANOVA with replication. So please have in mind the differentiation between sources of variation for one-way ANOVA and two-way ANOVA. Okay, so from here you can see because the above one you can see halfway. So you can see from the table of total, okay, you will have sum total and grand total. So this is your overall total of summation of each and every single response variable that you have from the first one until the last of your response variable. So from this grand total, you can find your grand mean. Okay, and the way you find the grand mean is by dividing the summation of all the y dot, means all the y response variable, divided by the number of total sample. Okay, so you will get your grand mean. Okay, and for the cell total, to find the mean divided by the number of samples for each level involved. Okay, now next, what else should you know is the way we find our sum of square. Okay, since our our ANOVA table will involve the sum of square total, sum of square for factor A, sum of square for factor B, sum of square of the interaction, and sum of square of the error. So there will be ways on how we can find individually for each of the sum of square. So I'm not going to discuss this further, but you can see if you wish to calculate the value of each of these sum of square, you can find using this particular formula. Okay, so now you should know that Yij is your response variable. Okay, response variable given in your table. Okay, in your table of this one. Okay, this particular table. This one. Okay, now next, so this is your grand mean. Okay? So this is your grand mean. Okay. Okay, so I'm not going to talk this further because last time, if when we have face-to-face lesson, we are going to discuss this in detail. We are going to do it manually. But since you are using your Excel, so I'm we not interested to go through the detail of how we can calculate this manually. Okay. Now, let us look at the example 4.5. If you can look at example 4.5, okay, on page, if I'm not mistaken, on page 138. Okay, you are given this particular setting. Okay, you have factor A, you have low and high, you have factor B, also low and high, and you have all the what we call response variable. Construct the Anova table for this experiment and do a complete analysis at 5% level of significance. Okay, so let's begin with the identifying the common terms in your two-way Anova. That will be by finding the number of replication, finding the level of factor A, finding the level of factor B, and then what will be your response? In this case, since we are not, we don't know the context of the problem, so I guess we just stop at this particular what we call discussion. Okay, how many replication do we have in this particular experiment? So the way we find the replication is based on the what we call on the given data for each level of your factor. So if you can see here, okay, you have for low level of factor A, you have two response variables. The same goes to factor B high with low of factor A, you also have two. Okay, and you can see you will have standardized number of replication. So in this case, the number of replication is 2. How? Because we have 1, 2. What will be the level of factor A? So we are talking about factor A. How many levels? We have low and high. So we have 2 for level A. What about level of factor B? We have also low and high. So we have 2. Okay. So how many N? 2, 4, 6, 8. You have 8 altogether, 8 response variable. So that's how you identify the number of replication, the number of level of factor A, the number of level of factor B, and the total sample or response variable given in your data. Now, how can we solve this? And the way I do the solution for this particular example, I will include the whole. If I'm not mistaken, I have covered the whole concept that you should know that has been written from. If you can look at your textbook from page 134, 35, 36, 37, and 138. Okay, so from page 134 until 138. Okay, all the concept okay, are being discussed in this particular example. So since talking about the concept would be very dry, so I think it would be easy for me to discuss the concept when we are discussing about the example. So it would be very much more meaningful that way. Okay. So if you have any questions, please stop me. Okay. Now, how can we solve the particular equations for two-way ANOVA, knowing that we are dealing with two factors, and as usual, we are going to start with the statement of hypothesis. Okay, since we are dealing with factor A, factor B, and interaction, okay, the way we set the hypothesis will always begin with the interaction. Okay, always begin with the interaction and then followed by factor A and by factor B. Now, what will be the statement for the interaction? Okay, the easiest one, the common one would be there is no interaction effect between factor A and B on the response variable. As simple as that. That would be the noun. So the noun will always no interaction. Okay, reverse to your noun statement will be your alternative statement. So there will be an interaction effect between factor A and B on the response variable. So here we are talking about the interaction. Okay, we know that factor A, okay, has the low and high, and then we are talking about factor B, okay, also low and high of factor B. Okay, so now we are talking about the interaction between low, 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 high, high, low, high, high. So we are talking about this particular thing. Okay, whether there is an interaction or not. So this will be the first thing that you need to test. Must be tested, as I mentioned in this bracket. Must be tested first. If the test result significant, what do we mean by significant? Means that we reject the null hypothesis, then stop. Stop at what? Stop until interaction statement, interaction test. Stop at the interaction hypothesis testing. Okay, if it appears that there is an interaction, then you don't have to test for the factor A effect. Okay, now if let's say your result for interaction, hypothesis testing for your interaction is not significant, means that we fail to reject the null hypothesis, then only we proceed with the factor A and factor B hypothesis testing. So if I can rewrite again somewhere here, okay, so proceed, okay, I have written, I think there's no need for me to rewrite again, I have written right inside, okay. So now class, only test for effect of factor A if the interaction effect is not significant. Not significant means that we fail to reject null hypothesis. Okay, means we fail to reject null hypothesis. If we fail to reject the null hypothesis, means that there is no interaction, then only we proceed with the factor A hypothesis testing and factor B hypothesis testing. So if you proceed to your factor A effect hypothesis testing, what will be your hypothesis statement? The noun will be there is no effect of factor A on the response variable, and the alternative will be there is an effect of factor A on the response variable. No, and there is an effect. The same goes to factor B. There is no effect for the noun, there will be an effect. So I think this is a typo error. So there is an effect of factor B on the response variable. Okay, so that will be your hypothesis statement. Then, since you are going to use your Excel, so I hope by now everyone have tried several what we call exercise or example using your Excel. Okay, let us look how we can use Excel to come up with your ANOVA table, given that you are having this particular table. Now, now, how does your ANOVA tables look like in terms of the what we call the things that are being given in your ANOVA table? Okay, your ANOVA table of your two factor will be this one. You will begin with factor A, and then you will have factor B, and then you will have interaction, and then you have error, and then you have your total. So SSA refers to factor A, SSB refers to factor B, SSEB refers to interaction, SSE and SST, I think you have understood how does this generated in your ANOVA. Now, you need also to make sure that you remember this. Sometimes we may ask you in terms of the true false question or multiple choice question, we can ask this particular understanding. Okay, so in terms of degree of freedom, in terms of sum of square, in terms of the source of variation, we can always ask you in this question in terms of general knowledge. So you need to understand this concept. Okay. So the degree of freedom would be the number of level for factor A minus 1. For factor B, the degree of freedom will be the number of level of factor B minus 1. And then the interaction, you just multiply these two, you will get the interaction. Okay, and then for the error, you multiply the level of factor A with level of factor B, multiply with replication number minus 1. Okay, and for your n total, or you can have as simple as n minus 1 equal, this is equal, so A multiply with B multiply with replication. So as what we have just now, we have 2 for A, 2 for B, 2 for R minus 1. So you will have 8 minus 1, right, which is 7. So we know that our sample is 8 minus 1 also 7. So that's how we can have the degree of freedom for total. And for your mean square, as usual, you are going to take the sum of square divided by the degree of freedom. Okay, and then you will get your mean square of A, mean square of factor B, mean square of the infraction, and the mean square of error. And for your F test, okay, for the F test, which is the calculated F, okay, so for factor A will be MSE divided by MSE. So all the denominator will refers to MSE. Okay, will be the denominator. So please make sure you remember how to calculate it manually in case you are being asked about the concept. And of course, the p-value, okay, you can find from your F table, but since you are using your Excel, this will be given by Excel, given automatically. Okay. So any questions so far, class? Any question? Class, any question? Hello?
No.
Okay. Can you please let me know how many students inside the Google class? The online online class?
46.
What was that?
46.
46 only. There should be 62, right? 61. Never mind lah. I don't I don't want to discuss that further. Okay. How can we use our Excel to come up to generate this ANOVA table? Okay. First, in Excel, key in your data, okay, as what you have in your table given in your equation. That's how you can put or key in your data in Excel. Okay, so we have factor A, low and high, factor B, low and high. Correct. Make sure you key in the correct value of your response variable. Plus, if you wrongly key in one of the number, the whole of your ANOVA table is useless. Okay, so before you can even go further to your second step, make sure all the data you have input in your table are correct. Okay, then only you go to data, click data, and then you will get data analysis. You click data analysis, and then you will get this pop-up come up. Okay, and you choose Anova two-factor with replication, and then click OK. Once you click OK, okay, so you will have this pop-up come up for you. Okay, so begin with specifying the input range. What will be your input range? This will be your input range. You can select this, okay, or you can select only this. That will be fine. Okay, both are acceptable. But remember, you know what will be referring to this particular row, okay, and what will be referring to your particular column. So we are calling this column and we are calling this row. So make sure you know the row is referring to what factor, A or B. Okay, then go to row per sample. Row per sample means that how many data for each level. For low, we have 1, 2. High, 1, 2. Basically, it will be a standard. If you have 4, then the rest will be 4. So this is referring to your replication. Okay, and your alpha, as usual, please make sure if you are referring your alpha 0.05, make sure here is 0.05. If you are being asked for alpha 0.10, then put it 0.10 here. Then specify in your output range. I always like to have my output near my what we call data table. So I will choose F1 where I will have my result. Okay, then click OK. Once you click OK, okay, this is how you will have your result. Okay, so this is the data that you have just now, you key in, and this is the first part of your result. And what you can see from the first part of your Anova result is the summary. Okay, now class, we are talking about factor A, factor B. Okay, now if you look at factor A, okay, so factor A, and then you will see, okay, for factor A will be at the first one. It will refers to the first, what we call, okay, so this is what we call factor A. A low, A high. Okay, A low, A high. Okay, and then what you have then, you will have your factor B that will be low and high. So for your factor B, you will have your, here is your factor B. Okay, low and high, the same here. So this is referring to the interaction of low, 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 high, high, low, high, high. Okay, from this result, okay, since we are going to use our table of total. So I generate my what we call table of total. But from here, I work from here. But if you have this particular result, you don't have to work from here. Just work from here and then come up with your table of total and table of mean. So the one that we are interested is this one. The one that I highlight, and then the row total, and then the column total. And then we have the grand total. Okay, so here it will be your result from your Excel. And then this is the total, the overall. This one is for the total. Okay, for the total. And then, okay, so the total is referring to this particular part. Okay, now what else will you have other than this particular summary? You will have your Anova table. Okay, this is how your Anova table looks like. Okay, the one that I put in the box is the one that I add later on. Okay, what you will have in your Anova table will always be sample and columns. So you need to understand what does sample means, what does column means. So always this will be the row, and this will be the column. Okay, so since we know that the column will refer to factor D, then the row will definitely refer to factor A. Okay, so you will have your interaction effect. So you have the error. So within is the error, SSE, and the total. So this is how your ANOVA table looks like. Now, what will be the second step that you need to further process will be the critical value of your F. Okay, since we are dealing with alpha 0.05, okay, so alpha 0.05, so we are talking about F alpha, we are talking about the first factor A minus 1, and then K minus, the interaction is A minus 1, right away just take the from your table, it will be easier. Okay, so from your table, we are taking the degree of freedom. If you are talking about factor of AB, okay, factor AB means that the alpha value, the alpha level involved, and then the interaction is 1, the error is 4. That's why we have 1 and 4. So this is for AB, and this is for error. Okay, error. And then for factor A, we are taking the degree of freedom of factor A and the degree of freedom of error. So that's why we have 1, 4. Coincidentally, you have similar value of A, B, and interaction. Okay, so the same goes to factor B. The alpha is 0.05. The level of factor A minus 1, and then the error degree of freedom, that is 4. So definitely, since everything is the same, so of your F critical value for interaction, factor A and factor B are all similar. Next, step 3, obtain the test statistic. Okay, so your test statistic is based on your calculation. Always remember, based on your calculation of your F, that will be by the whatever you are talking about. If you are talking about the A interaction effect of AB, okay, so you are talking about the interaction effect of if you're talking about AB, then you have NSAB divided by NSE. Okay, so in this case, NSAB will be this one. Okay, and then divided by NSE is this one. So you will get, okay, is it correct? Just to make sure, 2 divided by 15, 15.25. Okay, so you have 2 over 15.25. If you're talking about FA, then FA, it will be NSA divided by NSE. Okay, so it will be 684.5 divided by 15.25. That's why you get 44.8852. Okay, so that's how we calculate the F test. Now, having said that you have your critical F test and your critical value of your F and then F test of your calculated factors and interaction, then we make decision. Okay, so the way we make decision, okay, class, I forgot that you can see here your p-value is automatically given in your ANOVA table. Okay, so how do we make decision then? If you are using your F test and FCV, so look for the first one. If your F critical value is greater than F test, okay, then in this case it will be fail to reject null hypothesis. Or if it is p value versus the alpha, it seems that alpha is greater than the critical value. Okay, the p value, sorry, p value and alpha, sorry, this one is reverse, almost the same. Okay, so if I sketch, okay, so this is your F alpha, okay, and then this will be referring to your alpha, okay, and then your F test will be, let's say in this case, your F alpha is given by 7.71, and then your F test of the interaction is 0.13, which is very small, okay? So somewhere located over here, so this is your F test, which is 0.1 and falls in the non-rejection region, okay? Falls in the non-rejection region. So that's why we fail to reject the null hypothesis. Now, what if I'm using my p-value and alpha? So where is my alpha? My alpha is here, denoted here. This is my 0.05. Where is my p-value? Always remember p-value is given by the f-test. So this is where the p-value. Okay, so what is the p-value? It's the probability of rejecting. Okay, that will be this particular area. Okay, so this is where the p-value lies. Very big. Okay, so if you can see, the p-value is equal to 0.736, almost 1, near to 1. So we know that it is, in this case, we fail to reject the null hypothesis. So remember class just now I said, when we test for the interaction, what happens is that if we fail to reject, then we proceed to the next. Okay. Now in this case, we look for the effect of factor A and factor B. How does the result show us? Okay. Now settle with the interaction. Since there is no interaction, so we proceed with the factor A effect. Now, if we take the value from your Anova table, and let's say we have this, okay? So using the F test versus FCB, so the F test is 44.89 and FCB is 7.71. So if I were to sketch my F distribution, okay, so I have my FCB is 7.71. Let's say this is FCB, F alpha, okay, FCB, that is 7.71. And then I have my alpha over here, 0.05, okay, and then I have my F test, okay, that is 44.89, which is very small, okay, somewhere at the end of the distribution. And let's say in this case, this is where the location of your F test, okay, so F test is equal to 44.89, okay. So in this case, since your F test fall in the rejection region, then we make the reject null hypothesis. If you are based on the p-value, where is my p-value? This is where my p-value lies. So this is my p-value, which is very small, that is 0.002. And my alpha is 0.05. Okay, so class, in this case, what can you do next is test for factor B then. Since factor A is significant, since we reject the null hypothesis, then we follow with the factor B effect. See whether we can prove that it is significant or not. Now, the same with the factor A just now, if I draw the distribution, okay, so you have your F alpha is 7.71, okay, and this is your alpha 0.05, and then you have your F test is 17.34. So let's say this is where your 17, okay, so this is your F test, so falls in the rejection region, and we know that this is the p-value, okay, the p-value is given by 0.014. For fact P alpha, we can definitely see that it is fall in the rejection region, then reject the null hypothesis. So how do we make the conclusion then? Okay, let us look at the first conclusion that you can make. First, it will go back to your interaction effect. So the way we make conclusion will be there is insufficient evidence to conclude. Okay, so the keyword I highlighted in red. So there is insufficient evidence to conclude that there is an interaction between factor A and B on the response variable. Since this is not significant, okay, so we continue with the factor A and factor B effect. And in this case, both are significant. So the way we make conclusion would be there is sufficient evidence to conclude that there is a significant effect of factor A on the response variable. Now, class, please make sure the keyword sufficient evidence to conclude there is a significant effect of factor A on the response variable is the keyword for your conclusion. If you left out this, okay, then it will be wrong. It will be misleading in terms of meaning. The same goes to factor B effect. Okay, so in this case, not significant interaction, but significant factor A, significant factor B. So far, do you have any question, class?